I would like to invite Bharti to give a brief introduction about program Kalpana and introduce our speaker for the today. And yeah, we get started. And before that, I just wanted to say just a thanks, like a quick thanks to all of you for being here despite all the difficulties that we are facing in today's world. And thank you, Archana ma'am, for waking up at like, an ungodly hour and joining us from Switzerland. So yeah, over to you, Bharti.
Thank you, Darshana. Hello, everyone. So once again, this is for ma'am as well, and this is for all our audience who has joined us a little later. And so today we are here and we are welcoming our second cohort of Kalpana, which we are internally calling as 2.1. So Kalpana She for STEM, it aims to bridge the gender gap in STEM, which is disciplined by equipping female undergraduates and postgraduates with tools to explore the broader possibilities in STEM careers. So the program, Kalpana, it is determined to widen the access to opportunities for every aspiring undergraduate girl in STEM. We launched this program on 18th of October 2020, and which was formally launched by earlier Professor Ashutosh from DSC. Our first cohort, as I told earlier, was from 60 girls from 60 different cities and towns, where they got the skills. They were told about how to develop themselves interpersonally, gain the self-efficacy so that they can go about their career choices with full confidence with the professional tools that were provided by our mentors. So in our mission, we are very generously supported by leading researchers and scientists based at premier research institutions in India and across the globe, including Cambridge University, UK, leading women scientist and educationist Professor Shobhana Narasimhan and Professor Pratibha Joshi, who are our advisors. Ma'am Pratibha Joshi is not able to join us because of COVID, but I'm sure Professor Shobhana will be here with us. And so Kalpana, She for STEM, it has two major components. And during the fellowship, you will be exploring the first 8 weeks as the fellow. And later in the further 8 weeks, you will be doing the STEM projects and learning through the master classes and getting more exposure to the role models in the Kalpana network, where you will be getting more and more experience and you can always request a particular kind of masterclass which is required for your professional development to your mentor or to the Kalpana team. So here today we have our speaker, Dr.Archana Sharma, who is joining us from Switzerland today from Geneva. So thank you, ma'am, first of all, to join us at this particular time. And so to introduce Dr. Sharma, she is a principal staff scientist at the CERN laboratory, a well-renowned institution in Geneva, Switzerland, and active in the field of particle physics since 1989. She's mainly working on instrumentation. She is pioneer in simulations and experimentation on gaseous detectors, which uses high energy physics over the last 3 decades. She got her PhD in particle physics from Delhi University in 1989 and a DSc from University of Geneva in 1996. Dr. Archana has worked at CERN experiments on research and development and commissioning of large-scale gaseous detectors. Dr. Archana also serves as senior advisor for relations with international organizations at CERN and focuses on capacity building in India by her project Life Lab Foundation. And I would request for you all to check out the work later, what Life Lab Foundation is doing for education and research. So having Dr. Archana Sharma here, hello, ma'am. Over to you, please.
Thank you very much, Bharti, and thank you, Darshana. Thank you, the whole team. It is incredible. And if I may say so, कि मेरे आंखों में आंसू आ रहे हैं इस वक्त, that I am so privileged to be talking to a group of girls, a group of young enthusiastic women who are going to really take the future of our country in their hands, you know. Secondly, when I grew up, there was no such concept. And that gap is absolutely necessary. It's crying to be addressed. So I can only be amazed at the work you are doing, and hats off to all of you to take this initiative. And I'm all here in every way, whatever little I can do to consolidate the program and take it further.
Thank you, ma'am.
So can I share my screen?
Yes, please, ma'am. Bharti, can you make ma'am presenter? So.
I think you can see my screen.
Yes, ma'am, we can see your screen now.
Brilliant. So thank you for this invitation. As I said, I'm humbled at the opportunity. There are so many things that we can learn. And if somebody had told me 30 years ago that I could be doing what I'm doing today, I could never believe it. So that is very, very important to remember. You as a student right now, or as a mentor, or as a part of the scientific fraternity, you have the possibility and you have the opportunity to really pick up in your own hands future and curate it the way you want. And as I was hearing some mentors speaking earlier, that the better you define what you want to do, the more probable it will become what exactly you will do. So without too much of, getting carried away, let me focus on what I have prepared for you. And then, of course, feel free to prepare your questions. And at the end, I will be very happy to interact and to give answers, whatever I can. So I have been fortunate. I work at the frontier of science and technology. And there are many, many big experiments where India is participating. And these experiments are called mega science projects. Some of you may already know about them, and maybe some of you do not know about them. On the top left, you see that I have made a round icon where CERN is on the top. That's where I work, and I will tell you more about it. And there are many other mega science projects which you can just Google about. FAIR in Germany, Bell in Japan, STAR in Brookhaven in the United States, Fermilab also in the United States, LIGO now we have in India, in Pune, and the country also. There is the ION experiment and there is the ITER experiment in France. So India is participating in all these experiments and nothing is stopping you from being part of them. So it's just what you will imagine, that I would like to do scientific research, or I would like to work in the science, or I want to work in technology. Darshana, can you ask somebody to mute? There's a feedback.
I'm mute everyone. I'll just do that.
Yeah.
Thank you. So yes, you could be working at the cutting edge of technology. You could be working on the social impact of what science and technology brings about. You could be a business person. You could start up and do wonders with science and technology and the industrial engagement that comes along. So what exactly is CERN? CERN is an acronym. It's a French name because we are here in the borders of Switzerland and France, where people speak French. It's a Conseil Européen pour Recherche Nucléaire. And that acronym actually stuck there. So without looking too much into the language, if you look at exactly what is done, it is about fundamental research. And fundamental research is about asking questions. And when we are asking questions, we are driving innovation. And this investment, is there a comment?
Yeah, sorry to interrupt, ma'am. Darshana here. Ma'am, आप slide change कर रहे हैं क्या? We can't see anything after the first slide. It's just stuck at the first slide.
Wait then, please give me a second. Let me check what's going on.
Yeah, now it's changing. आपने अभी कुछ तो किया. Now it's going on to the third.
Yeah, but I want to have it in the in the mode, for display. Let me check again if I can do that. Let me try like this. No, you cannot see that. Can you see my screen? Is it changing?
Ma'am, not now. It's on the CERN Fundamental Research Thrives in International Collaboration slide. Yeah, now it is changing. Curiosity, yes.
Yeah, okay, so I'll have to do something else. I'll have to just use without the screen mode. Is that all right?
Yes, ma'am. That's okay.
Okay. So yes, fundamental research is of course what we do at CERN, and this research gives very big dividends over time. That I'm going to walk you through that, and maybe flash a few words that you may have heard before, like the Higgs boson, the God particle, the Large Hadron Collider. This is a very big accelerator at CERN, which which is the main instrument, excuse me, that we use for all our experiments and a little more as well. You have heard of course, the words WWW, without which we do not exist, as you know today in this world of pandemic. I think 90% of our time we are sitting with somewhere in the WWW. And I hope that some of you do know that this WWW was invented at CERN by a 23-year-old young student, just because he wanted to share the data that we generate among the scientists on different computers in different locations. That's how the whole thing started. And of course, there are future machines like the High Luminosity Large Hadron Collider, and we look at it. So the whole thing starts from curiosity. And I think I will give you all a 10 on 10 for curiosity, because you are here just for the fact to understand what's going on, for the fact that you want to hook up and you want to leverage your own potential into the future. That itself represents that you are curious, not only about yourself and what difference you can make, but also of the whole universe. I'm sure all of us have had this question when we were a kid: where did we come from? And where are we going? Where did the universe begin? What is time? What was before time? Right? These are kind of questions that keep coming back and forth in our minds. But then, we get busy in our daily routines and we forget about the questions that keep coming back and forth in our minds. But given this curiosity is what drives fundamental research. So one question is that suppose Darshana wants to shake hands with me, and let's imagine that she is made of antimatter, okay? And if we shake hands, what will happen? Matter and antimatter should annihilate, isn't it? And then there should be only energy. But that does not happen. It means both of us are made of matter. And that is a mystery, because at the time of the Big Bang, you may have heard of the Big Bang that happened about 14 billion years ago. Why did matter remain, and where is all the antimatter disappeared? So these are the kind of questions also that we try to ask. In addition, right now we have already moved how many kilometers? Because we are moving at a speed of 220 kilometers per second. Along with the solar system, we are moving. The Earth itself is moving, as you all know, and the whole galaxy is moving very fast. But it is all relative, of course. That's why we do not feel it. And there is gravity that keeps us on the surface of the Earth. Otherwise, we will disappear somewhere. The moon is there because of gravity, and so on. The whole galaxy and the whole universe essentially is in its place. Of course, it's moving as well because of gravity. So what else are the forces in this universe? And we try to look at those questions. Particularly, these are many, many open questions in science. Some of them I already hinted to you, like the matter versus antimatter. But then there are other questions also. Questions like what is an electron? What is a proton? And why is it different from each other? Why is a proton so heavy? And why is the electron so light? You have heard about these particles, right? And that's where we call particle physics, because we study the elementary building blocks of the universe. You know, suppose if if we were to create the universe once again, what will be the recipe to create this universe? And those are questions which we ask in our field, and then we try to answer them by doing experiments. One of the pioneers of these kind of experiments or instrumentation, like Bharti was introducing me, and she said that I work on instrumentation. So I ask the question, that's fine, but then there are a number of theoretical physicists, huge number of theoretical physicists, and in India we have a big legacy of them in the Tata Institute of Fundamental Research, in the IISc Bangalore, in VECC Kolkata, and you know that there are so many institutions where we have leading scientists who have been doing in the past and also in the present working on these questions and trying to find answers. Rohini Godbole, you might know, she is also a champion, by the way, also of gender diversity in our field, and also Padma Shri in high energy physics, theoretical physics. So I work on experiments. On the right, you see my experiment. But on the top, you see a lady here, and her name is Bibha Chaudhary. And she was working in Kolkata, where she started working on instrumentation. She built small instruments in the early 40s, 1940s, and eventually in 1950, for her instrument that was then developed further in the West, Powell got the Nobel Prize. It means that she actually created the grounds on which other people could work. In a similar manner, we are all standing on shoulders of giants like Bibha. So we have to acknowledge and um, and understand that without taking the knowledge from the past, we cannot be moving in the future. So these pictures are very well known to you. I'm sure there's nobody in the audience who doesn't realize the impact these two scientists have made on us. That's Sir Isaac Newton, Albert Einstein. And without going in the theories, you all know that today in our world, whatever we use, let's say we are using a GPS, or we are traveling in an airplane, or in a bus, or in a railway train, everywhere technology is used, making use of the equations, even some of the very complicated equations that have been elaborated on theories standing again on the shoulders of giants like Einstein and Newton. So I hope I have convinced you that we need to ask questions, and you are going to ask questions about the universe and about what connects you to the universe. And that is very important, because when we begin our career and when we are in a younger, let's say, stage of our lives, we do not see the interconnectedness of life and of the impact of whatever we are studying. Today, look at the pandemic. It is incredible to imagine that we are not related to each other. I feel guilty of breathing fresh air where I'm sitting today, because I suffer for the fact that my compatriots are in so much trouble. There was trouble here also. Don't let me not make it so romantic. You know, it was very, we had 3 waves already, and it's still not over here. It means that in India also, be very difficult for the next 1 year, 6 months. It's going to be a challenge. So everyone is related to each other, and the air we breathe here is going to go around the planet and come to you at some point. Now, we all began at the point of the Big Bang, when we were all together physically as well, in called the cosmic soup. You know, so when we were all not even protons, but some form of matter, we were all together in this cosmic soup 14 billion years. And that's the Big Bang theory, which tells us how from that cosmic soup, the first particles were formed, the first light was formed, atoms were formed, nucleus were formed, and how the four forces like gravity, like electromagnetism, like the weak force, and of course the strong nuclear force, how they manifested themselves. And from the first few milliseconds or seconds, we were able to convert into the universe like we know it today, right? And today we have the duty to think and to imagine, how does this all connect? Whatever I'm studying, how does that connect to the bigger questions of the planet, of course, and in the universe? If you pick up science, and if you pick up particle physics, there are many that I was explaining earlier. So yes, we are getting the food on our table because of science and technology, because some farmer is working somewhere and then the food comes on our table because of transportation. Sugar is coming from another country, or all these things, of course. But all that has come because of asking questions and studying fundamental science, which means STEM, of course. So yes, we have asked questions. Now let us do an experiment together. Both of us are going to do this experiment. Let me try to play. Can you see my slide here? And I hope it plays.
Yes, ma'am. Collision energy.
Yes, ma'am.
Okay, does it work? Is it working?
I can see collision theory, but I can't see anything moving.
Oh, just let me try again. How can I see? This is not good.
I believe they are supposed to fly.
You're not in full screen mode.
Sorry?
I think you may not be in full screen mode, because I can see little slides on the left.
Yeah, but that's why I am on full screen mode and you're not able to see my full screen. So I'm going to try maybe sharing again, and maybe there's some sharing that I could improve. Let me just give me a second.
Ma'am, in screen sharing, you can share your screen instead of sharing the presentation. So
Good idea.
whatever you
Very good. Very good. Thank you. That was it. I think that will work then. Let me try. Where is the... No, I made a mistake again because I did because I was sharing the application, not the screen. That is the point. Let me try. How can I do?
You stop sharing first. Stop sharing.
Yeah. Okay. Then I say desktop screen number 2. So now you're seeing my screen too. Is it correct? Is it okay?
We're not
Yes,
seeing
ma'am.
anything yet. You can see? Okay.
No,
Is it okay?
I can see your whole desktop basically. So it is not moving though.
It should move now. Is it okay?
Yes. I think if you click now, it will.
Something happening?
Yes, ma'am, happening.
Okay, thank you. So I have to go back because you missed the beginning in all this mess. I'm sorry, I should have known this before. So I started with 2 helicopters that are made out of Lego. Did you see that? I think you did. And these 2 helicopters, I tried to smash them together. And when I smash them together, they break, of course, and they break into pieces which I could probably put back together as helicopters, because I could make out what they came from, right? So that is the kind of experiment that I wanted to do with you. Let us try to increase the collision energy, okay? And let's see what happens when we increase the collision energy. Oh, they now break up into fundamental particles. So that's matter. My helicopters are made out of matter. And for this exercise, you have seen that they break down now into little pieces, the most fundamental pieces with which they were made. So when I do my experiments, I'm able to break matter into fundamental particles. Now, you believe me that this has happened, and that when the scientists have been continuing to do these experiments, and what they have, that there are many small fundamental particles. Some of them you know, like the electron and the proton and the neutron, but there are many more as well. And when we put them together, of course, scientists like to simplify. You have heard of E is equal to mc squared, correct? And there is another complex equation, but it's not that complex because it can fit on a surface of one coffee mug, right? And this is the experiment that describes the forces and all the particles with which we are made, with which the universe is made, and how the whole universe moves. And that also explains, it's the best theory that we know of how we came into being. So with one equation, so many scientists over the last 100 years, more than 100 years, have been able to put together the theory that you know very well, which is the understanding of matter, how matter is made. And we already spoke of atoms, we spoke of protons and neutrons, we spoke of the atomic nucleus. And remember the experiment, our helicopters, when we smashed atomic nuclei with each other, we were able to look what is inside the nucleus. And when we saw that there were protons and neutrons, we also smashed the protons together and we found that they are made out of quarks and leptons. Lepton is the electron, of course. It's another name for the electron, simply because leptos means light in, and quarks are the heavier particles. They are the hadrons. That's the model that we know. And how did we know this? We have been smashing things together. So scientists are very funny, you know, they love to do smash things and they love to make little models. And you see now with our knowledge that we have with some of the quarks and the electron together, we are able now to make an atom. Okay, so this is assembling a helium atom from the knowledge that we have, and you can see. Now you must be wondering, what is the importance of all this? You know, fine, we know about the structure of the universe, etc., etc. But imagine that the humble electron that was discovered more than 100 years ago is today serving a purpose for our life. You must have heard, some of you may have heard about quantum mechanics. Some of you may have heard about the scanning electron microscope. And there is a transmission electron microscope, there is a cryo microscope, and so on. All that is based on the fact that the humble electron was discovered by Thomson in 1899, right? So today, when you have to find a vaccine, first you have to understand what the virus looks like, isn't it, for COVID? And the first pitch that came out was thanks to electrons. And now I don't have to harp on the idea that this is a very fundamental implication of studying things that look very complex, but then eventually they come into our society in one form or the other, that we are able to exploit the science for opening doors for society. And I would like you all to think that what your contribution. You know, not everybody will become an Einstein, and not everybody is going to make those kind of, you know, dramatic contributions, but every bit counts. You know, every drop in the ocean is important, and you can contribute by a drop, by looking at the questions we have been thinking of, and we do not know the answers about them. You want to imagine, what can I do in this scenario? Okay, so now back to our favorite game. These are my two helicopters, and you will play with them by smashing them together. And what happened this time? Oh, we did not get anything that we were expecting. Is it correct? We were not expecting these dinosaurs. We were expecting Lego pieces, smaller Lego pieces, and so on. But what happened? Believe in dinosaurs? I think yes. But why do you believe in dinosaurs? Because you have seen the remains. You have seen their signatures or fossils, and you've seen them in museums or in movies and so on, right? This is not something that is just a figment of imagination. Similarly, at the time of the Big Bang, there were particles that do not exist anymore. They are extinct, or if they exist, they immediately decay. Okay, so that is the next smashing game that we are playing with the Large Hadron Collider. That is this accelerator at CERN, where we convert from energy some into mass by smashing particles together. And when we smash them together, we are able to make particles that do not exist anymore, but existed at the time of the Big Bang. And you may have seen some these kind of pictures, beautiful pictures, and they are coming from CERN, and you see there's a collision point in the center, and lots of debris is coming out in the collisions. And what are we doing as scientists? Of course, I am nuts and bolts, so I'm making the instruments that are measuring these energies and positions. However, these are big, big experiments, huge experiments, like spaceships, you know, and each part of this spaceship is a camera. So imagine any dot that you see here in this picture is a camera taking pictures of the collision 40 million times in 1 second. Technology. Okay, 30 years ago or 40 years ago, if somebody told me that we could speak to another person on another planet, or maybe in another continent already, it was quite a magic, so to speak. And today, this is amazing that we are able to do that. But that's technology. So what's happening here? We are colliding two beams of protons. They collide and they generate in a very, very tiny space temperatures that are over 1 billion times higher than in the center of the sun. And then they produce those particles that may have existed at the beginning of the universe after the Big Bang. So Einstein, everybody knows and everybody loves, so I don't resist showing him again and again. Now imagine our collision. So when these protons, they are accelerated, they collide, they make not only the dinosaurs, but they make a lot of things. Some of them are known particles and some of them are unknown particles, unsuspected. We have surprises. We are waiting for surprises, actually. And of course, many of them are hypothetical theories, future. You know, they theory that there is an alien particle, and if we can find that alien particle, that will be amazing. So there is, of course, some things that are very expected. And what is that expected thing that we were looking for at the Large Hadron Collider? So remember the question I raised about mass, why electron is so light and why the proton is so heavy? There is a mechanism been put forward by scientists and theoretical physicists over the last many, many decades, that there is a particle called the Higgs boson. Okay, and this Higgs boson gives mass to other particles just by the interaction between them. So imagine that there is a large stadium in India, not in the pandemic time, please. So just imagine, just in your mind, you imagine it is full of people from all over India or from everywhere else. And these people, they will be different from each other, right? They will be very different from each other. But then imagine that from one end of the stadium, a star walks inside. So who could be a star in times of today? Anybody? Darshana, tell me the name of a star in our country.
I would say Shobhana. She's here.
Virat Kohli,
Okay.
I think.
Okay, Virat Kohli. Let's say Virat Kohli comes from from one side, and that message goes across the stadium that Virat Kohli is walking in from gate west. Okay, something will happen inside, right? All people will start to either talk to each other in a very excited manner, or they will start moving towards Virat, isn't it? And some people might want to take autographs and things. And even without physically meeting, just the knowledge that somebody like Virat is there at the other side of the stadium, been some movement inside the among the people, and the amount of, let's say, the quotient, the fan quotient will also be one of the factors on the amount of excitement that I will get when I'm in the stadium. This is the same way like the Higgs boson works. You know, the Higgs boson is there, and particles, they start getting interacting with the Higgs boson. They get a certain mass, and that mass is dependent on the interaction between our star and our people, and our Higgs, that is the star particle, and all the other particles that we have, the fundamental particles that make up the Standard Model. Okay, so how now we want to find, of course, theory is very good, but we want to find this Higgs boson to prove that it is true and it's not a figment of imagination. So to search, we need accelerators, because we have to do the smashing, correct? Then we need detectors to take pictures of these particles, of these collisions. We need a lot of software, we need computing, we need to trigger on good data, etc. And that all has to be done by younger people like you all, who will bring in new techniques and new algorithm treatments and so on, with modern techniques of machine learning and data analytics. And of course, without collaboration. Remember one thing, girls and everybody, that without collaboration, we cannot do science. Without collaboration, we cannot do anything in this world. Look at the pandemic. The pandemic solution lies in collaboration, or global warming, the solution lies in collaboration. And we have to now forget the old paradigm of competition. We need to collaborate, and we need to understand what can be complementary from me to you and from you to me, because everyone is unique and they bring in special qualities and special, how can I say, knowledge. So this is a picture inside the tunnel, which is at CERN, where the Large Hadron Collider is housed. And you will see that there are 1,200 of these 18-meter magnets spanning 27 kilometers, making up the largest microscope on the planet, so that we are able to look inside. You see these two beams, and these two beams, you don't see the beams, you just see the you see the cross section of the beam pipes on the left, and there are two beams that are circulating. They are protons that are sent through these two beam pipes, one set in the clockwise direction and the other set in the anti-clockwise direction, and then they collide at various points. And these points are where the experiments are located. Of course, all this is underground, and about 100 meters underground, there are 4 experiments where these collisions take place. We straddle 2 countries. One is on the right on the top part of the page, and on the bottom is France. And the protons, they go 11,000 times in 1 second before they are colliding at these experiments. All right. So top left is the accelerator, bottom left is a part of the experiment, top right are the computing facilities at CERN. And of course, with the WWW, we send off all the data to the whole planet. So if you are interested, you can hook up and look at what we are doing. So this is an aerial view of where I am and where this experiment is. You can see the airport of Geneva on the bottomish side. So that gives you a sense of scale. And this is 27 kilometers circumference. And the 2 countries are divided by this dotted line. And I am sitting somewhere on the bottom of the page speaking to you. These are the way experiments look like. Imagine a very huge space shuttle, but then it's not a space shuttle. Imagine that it is a cylindrical onion. Okay, then we slice it into pieces, vertical pieces, and each cylindrical onion is a sensor, a detector, a radiation detector, which will then take pictures of our that happen right in the center of these 2 experiments. There another picture, the experiment where I work, that's the compact muon solenoid, CMS. Nice pictures to show it is a and a marvel of technology that we are able to create sensors and detectors of different kinds, because different particles need different sensors. So you need to be very accurate in time. You have seen the tracks that go through your sensor, and also in space where your particle has gone through. So creating this experiment has been an amazing exercise that I was also in the big team, of course, and lowering large pieces, which are thousands of tons from the surface underground, has been quite a journey. So I have been participating, as you see here on the left, that's me in my experiment, and on the right side you see one of the detectors that I have built the whole, let's say, concept and brought into this experiment. The last piece of that detector is being installed in this picture. It doesn't say much to you, but I hope this picture will say something to you, because here in 2019 we moved that last detector to the experimental site. I'm sure you notice many girls here, right? Because in my teams, I try to focus at least 50% of them are girls. And I think, Darshana, that could be a good target that, in 2025 or 2030, we have 50% target for girls in STEM in our country. It's very, very ambitious, very dramatic, but we have to be bold and make bold targets. So that's somewhat in which direction I am moving. So these are nice pictures to show you how happy we were, and we also got with all of us together when we installed our last detector. Voila. And so again, I have to focus on the word collaboration once again, because this work, the scale of work that we do, is impossible without collaboration. And there are thousands of people who are working together to actually leverage the power of collaboration. And of course, the challenges are many. One is the data challenge, the electronics challenge. You have to change your mobile phone every 3 years, or your computer has to be changed because memory is not enough, and so on. Imagine where because we are the largest data producers on the planet. All the data of all telephone services of one full year on the planet is less than the data that we produce. So that's a challenge. And remember, what are we doing all this for? We are doing this to look for of particles that existed at the time of the Big Bang, but do not exist anymore. So the Higgs boson, to look for the Higgs boson is as if you have to look for a little needle in a haystack maybe much more haystacks actually. And also, to make the Higgs boson is very improbable. So we will be able to find one Higgs perhaps in 10 to the 11 to 10 to the 14 collisions that we make, right? So this was unbelievable, but in the end, we found it. And in both these experiments, Atlas and CMS, you need 2 experiments, because if one experiment, then maybe they have made a mistake. So if 2 find it, different technologies and 2 different techniques, it seems that it could be true. And this is exactly what happened in 2012. What you see on your screen could be confusing, but don't look at so much. But this is to share with you that these are slots that brought a lot of excitement and a lot of sales and a lot of, let's say, happiness to the physics community all over the world, because the little bumps that you see that are circled are the signals of the Higgs boson, sitting on top of all the background that we have measured. And we measured this in Atlas, and we measured this in CMS. And they were broadcast live to the whole world. There was an announcement at CERN when there was a seminar that was happening. And in this seminar, you know, I went in the morning at 5 o'clock, and even then I didn't get a place in this conference room. So I watched it like you, but this was an amazing announcement, as you can see. And on the bottom left, you see Fabiola Gianotti, a woman, the first woman Director General of CERN, and the first Director General of CERN who got a second term. So she was already there from 2016 as a Director General until 2019. And then from last year, from 2020, she has been extended for a second term. So this is unbelievable, but very, very motivating as well, that, you know, she is a woman. She's coming from Italy. She works very hard, just like all of us. So anything is possible if you have the target and the focus that you wish to do. 1 year later, these two gentlemen, the picture you see on your right, they got the Nobel Prize because Professor Higgs was the one who had proposed, and that's why we call the Higgs boson, that was proposed by him, a particle that gives mass to other particles. It sounds very esoteric, but when you look at all the applications that you use left and right, you imagine that these studies have been impactful. And on the right, you see Professor Engler, who also got the Nobel Prize along with him. On the left, you see our Director General at that point of time in 2013. And of course, in the bheed, you know, you might find me somewhere hiding and celebrating the Nobel Prize that was given for the work that was done at CERN. So imagine thousands of people. In CMS alone, we are 5,700 people. In Atlas, a similar number. So together, these 10,000 people, they got together and they found the Higgs boson. And that's the power of collaboration. And of course, we have the India CMS team as well that participated in this search and participated one way or the other by doing some analysis, by developing an algorithm, by building a detector, and so on, right? So everybody has been participating, and you see a large number of girls in our field. And I am very happy to see that, I must say. So yes, at CERN, that's where the World Wide Web was born. I already mentioned to you, there are many countries that are the member states of CERN. They are European member states, but India is an associate member. And of course, all of you have the possibility of participating, contributing, studying, doing your master thesis, even bachelor thesis, and so on in this field. So yes, we have done so much, looked at what we do at CERN. Now, how about looking at some of the applications of what we do? So when I was studying my BSc, I have to tell you, I was quite lost in my mathematics classes, and when I was given to solve very complex equations, complex calculus was given, I was not able to relate. Why am I studying that? It was very difficult. And today, none of you have any excuse to say that, because given the World Wide Web, given the support of people like Darshana and Bharti and all these, the teams that are in India, teachers, YouTube, you have everything possible that you can dream, and then you can do it. You can be here right now, you can start the journey, right? Whatever you have studied in terms of using the grid computing, that was something for number crunching that was invented also with our experiments, that is now used for meteorology, for weather forecasting, because so many lives and money can be saved by accurate weather forecasting. So yes, we have our accelerators, and you know that we also have our detectors. But you do not know that more than half of the accelerators operating in the world are used in health therapies, and particularly for cancer. There is a new technique called hadron therapy, and this has been originating from CERN. And this is a project that is very close to my heart, because this is what I would like to really bring bring about in India. And I'm actually working very actively on that, I have to say. But it has not taken traction as yet. but I'm going to continue that simply because, see, the pandemic, it struck us like a bolt from the blue. We had no idea that this is coming, the pandemic. And cancer is a known. We know that in our country we have like 1.5 million new cases per year. 1.5 million is how much? But you have to see in lakhs and crores. I always make that mistake, but I will try to see. Oh, 1.5 million is 15 lakhs? No.
15 lakhs.
Okay.
15 lakhs.
So you can work out the number of the cancer burden in India and in South Asia in general, because there are no machines in all of South Asia of the type that I'm thinking of. And why is this so special? Because if you look on the bottom right, you look at the X-ray radiation treatment that is given for a cancer patient, it actually damages healthy tissues and hurts the patient. But the way we use accelerators and heavy ions together, you are able to use a digital scalpel to remove only the tumor. And this is really something very close to my heart. And I'm trying to push, and I mean, it's a huge project. It can't be done overnight, but you will hear from me. And anyone would be interested and be ready to come on board will need 2-3 years. And in that 2-3 years, I would like everyone who is interested to prepare and to learn techniques, and even if it is software or electronics or safety or whatever, there are many ways in which people can contribute. So yes, accelerators will treat the tumor, imaging will give us nice pictures with low doses. When we go to take X-ray in the hospital, the technician disappears from the place simply because we get a high dose of radiation when we are taking an X-ray. So lower doses and better quality of, that's another application that has been uh, and it is actually being, billions of dollars are being made using the CERN technologies. So just sharing with you, just to show that what are the possibilities. Pick up, do something of that is actually possible from technology to the society. This is another grid computing. Look at these nice pictures. They are all made out of the detectors that are used in our experiment. This is from CMS experiment, by the way. And imagine the doctor's delight when he looks at this picture without actually going inside the body or cutting the body. It is a non-invasive picture made by taking slices of the slices, meaning radiating and taking pictures of every slice where the radiation is actually going to stop in the body. So there are new projects on the horizon until 2015. They are being defined and they have been approved as well to some of them, not all. And the next collider will be called the Future Circular Collider. And that's where young girls are going to take leadership. And I would absolutely love to see some of you there in this project, which will start in 2035. But it means that before that, we need a lot of practice, a lot of training and preparation, which is 100 kilometers in circumference as compared to the LHC that is 27 kilometers. So imagine the dream that is going on. And of course, that's where you come in, because who would like to be a part of it. And that's where my focus, like Bharti mentioned earlier, in India particularly, is that we can engage in a much bigger way and make an impact in a much bigger way in what we are doing. So my foundation, sitting here outside the country, it's not easy to marshal a lot of effort, but whatever little interaction I can do, whatever little exchange information and hands-on work we can do, we try to do with our foundation. So I'm pretty sure you feel confused and quite bewildered and disoriented with all the information that I've given you. I think it was huge amount of information, but there is hope. And why I say so? Because I fell in the ocean and I did not have Darshana and Bharti to tell me how to go ahead. And this picture is of a long, long ago, you know, when I was in school in, right? And that's in the middle, top middle, you see myself building my first model. You know, I built an electric crane, I still remember, with an electromagnet. And on the bottom left, you see the Geneva University. And I didn't have Delhi University where it disappeared. Okay, I have a picture here which has moved out meanwhile. And on the bottom right, you see a picture of myself in the CERN laboratory when I came here for the first time. And I had never seen this kind of electronics before. So this is 1986. And of course, electronics has completely taken, completely changed until today from that time. But even that in India, did not have the opportunity to study with these kind of electronics and other stuff. So that was the reason why I did my DSc that was mentioned earlier. And that's just another PhD which I did from the University of Geneva, so that I could study and learn the tools and techniques that were needed for my work that I was doing. And I was completely perplexed when I was thrown into this new world of CERN. But I went on, continued, and now I've been working in my laboratory. I've been bringing people together. I've been building collaborations which are spanning 17 countries and 40 institutions. My projects have given 70 PhDs. And I am like really proud, not only of myself, but also of all people with whom I have worked and learned from. So that has been really an opportunity. And you see, this is where I have installed this new technology of which we have some patents in the CMS experiment. And you see part of my teams who have been installing there. So here, these are some of the work that I have done in India, and with teachers as well. We have trained about, I think it was 100 teachers last time, and we were supposed to go last year. We couldn't go. This year we couldn't go, but I'm hoping that next year we can go back again and we can do many, many things in our country. And of course, my focus is with doing this with women and girls as much as I can. Now, it doesn't mean that I'm here doing great things, you know. In our field, we have many women leaders, and I'm very proud to say that these are the Indian women who are doing amazing work in our field in high energy physics all over the world. Okay, so the moment you will look, you will see that on the right, you see Rohini Godbole, and Rohini is in IISc Bangalore. Tulika is in University of Wisconsin on the top left, and Meenakshi is in the Brown University, the one in the middle on with a jacket. So yes, many of them are working in the country or at CERN, and I invite you to look for what they are doing and how you can connect and how you can build your network, which is very important, and learn. That's also very important. Do not think that there are other people will do the work for you. The work has to be done by yourself, and that's where the growth happens. So yes, if you can do particle physics, or if you can do physics, or if you can do some electronics, computing, you have an amazing set with you, which means you can go off and do anything that you dream of. And in our field, 90% of our PhDs go to industries, which means that they do not come back and do research, but they are using the work that they have done for the industry. And out of that 90%, 70% go into banks and finance sector, apart from, of course, the medical imaging and engineering fields that they do. In India, there are highly demanded in industrial sectors, which I don't have to explain to you. You are right there and you know exactly what is needed. And I have seen this report which says e-commerce, infrastructure, information technology, healthcare and retail. These are the big demanded industrial sectors of India. And how can I connect? That is the question you ask yourself. And that's where this comes into creating dreams and curating them very, very sharply. And that one can do by looking at what exactly does the world need. And I know these are very big questions. And when I was your age, I had no idea. I'm telling you, I was completely lost. But today we have the United Nations that has set for us sustainable development goals. And you can connect that how the world should look like in the future. And there are these experts who have been thinking of 5 years on what these goals should be. And India, of course, is part of this whole development, and India needs us more than ever now. So you can connect with these goals, and for example, you don't have to connect with each of them. There are 17 of the goals, but you can pick whatever is close to your heart. Good health and well-being, quality education, gender equality, climate action, partnership, etc. So I would encourage you to think of upskilling yourself, and opportunities come naturally. When you have a skill, people will, hoover you. They want you all the time. And then you look at what are our national priorities, and link them to international mega projects. So this is incredible, and I personally feel very charged to be able to do drop in this big ocean of the world of science and education, and particularly STEM, particularly engineering, technology, because that's work that I have done for the last more than 30 years. So with that, I would like to come to the end of what I'd like to say to you, and I'll leave you with this picture.
Thank you so much, ma'am. This was a wonderful talk, and how you brought the amalgamation of all the fields, like interplay of computer science, mathematics, physics, and of course how all the developments that have been using biophysics and being used in biophysics for the healthcare. I am myself doing cryo-EM and cryo-electron microscopy. And when you said that the coronavirus structure first came from electron, so that was it. I think you were mentioning about the cryo-EM at that time. And as I understand the accelerators and everything that you mentioned, people are using to determine the structures of biological molecules to use these accelerators even in synchrotrons. Am I right, ma'am?
Yes,
I hope
just a
so.
second. Let me just get back to my screen.
Yeah.
Where can I? Oh, it's here. It's hiding somewhere. Sorry. How can I come here? Yes. So that I can see you.
Okay. But ma'am, we can stop
Yeah.
you
Can
can
you
stop
stop my
sharing your
share?
screen if you.
Yeah.
Yeah,
Could you
okay.
please? Yeah. Thank you. Okay. Yes, I'm here.
Yes, ma'am. So we have actually multiple questions, and here from the fellows. And I would, because I, being a biologist, and what I'm doing biophysics, I can pick first biology question and probably then I will move. So
Absolutely.
Mansi is asking, does CERN offer positions to a biology student, and what can a biologist work upon at CERN if they can?
So thank you for the question. And I think that there will be similar questions that will keep coming, which are that how can I work with CERN? This is a very typical question and a very legitimate one, because now girls are charged up and they want to do something and they want to come to CERN and they want to do many, many things. So it's a common question. I'll just maybe address it more in a common way, which means
Yeah.
that at CERN, there are many, many, many opportunities. You would like to go to a page called careers.cern. Darshana, you might want to write it down and then maybe share it later.
Yes, ma'am. Yes.
And there you will see that there are all the opportunities that CERN offers for young
Okay.
undergrads, graduates, postgraduates, and so on. In biology, today safety is a very big concern. Radiation safety is a very big concern as well. So biologists per se are not employed, but if there are projects that are looking at biosafety or radiation safety, there are definitely, I know of one biologist who was hired and who is now retiring as well. But then I would like to come to a bigger picture from India, because the whole of CERN can't come to India and all of India can't come to CERN. So we need to understand how we can hook up with these mega science projects in India. So start from there. That's the way to do it. If you are very young, just starting your undergrad, go and take an internship in one of the Indian laboratories, in Tata Institute or in IISc Bangalore, HRI Allahabad. I mean, you look, which is why I showed that book of mine. It's supposed to be free, by the way, on the web. And there are links. I think there are 3 pages of links of all mega science projects in physics, chemistry, and biology. So, and in our country, we have highlighted scientists from our country who are doing Nobel winning work in the country. So, and they are connected to the mega science projects. So once you have the connect, you can always move within the mega science project and contribute from wherever you can. I hope I answered it in some way.
Yes, ma'am, indeed. And of course, not everybody can go and join CERN, and they have to have the key potential, of course, to join there as well. So keep working hard, people who are coming from different backgrounds. And as Dr. Sharma mentioned, there are very good institutions in India. You can start your journey from there, and probably then you can make your way somewhere else. So there is another question. How does data science contributes to fundamental research? Um, or how is data science and machine learning contributing to astronomy and astrophysics research in today's time? And what will be the significance of these tech fields in the domain of physics in coming years?
I think data science is something very big already. There are many, many big mega science experiments in astronomy that are looking at various issues that have to be resolved. And without data science, it's not possible. And I think, I mean, it depends from which perspective are we looking at the question, from the perspective of a student or a perspective of a researcher. So we have to look at developing algorithms. In particle physics, of course, this is the key skill, that is one of the key skills that is needed in terms of data analysis, data algorithms, triggering and looking, separating the data between good data and bad data is a very big skill as well, which then is used for trend analysis for rest of the data in the world. Today in health, let's take the pandemic. We need to be able to look at a large number of data and make evidence-based decisions. And how do you get evidence? You get evidence from data. This data comes from perhaps satellite imagery or from vaccinations, or you do not know where the data is coming from. However, one has to be able to look at evidence-based decision making, and that will then go into policy making. I'm speaking the jargon, so to speak, at the moment, but it will set in your mind to at least look for how these things are being done. So yes, data, treating data is very, very big today.
Indeed. And I can see like all these applications also of physics. Every application instrument generate a lot of data, which needs a lot of computing and later on. So yes, indeed. And there we have even more questions. So what are the best universities in Switzerland, Canada for pursuing masters in mathematics, and what are the best career opportunities in Switzerland and Canada after masters in mathematics? I think students are more focused about going to Switzerland or going to Canada. So yeah.
Okay, see, I mean, my standard answer is that first you have to imagine what you want to do. You can't just look at universities and then think, okay, what I want to do. First, you need to know, or at least look at options. I would spend, a month or two in one of our big institutions in our country to understand if really that's what I want to do. Because, you don't want to be pushed in a field and then get a degree and then be very sad that I don't want to do this for the rest of my life. So I would suggest to do a little introspection and question about universities, etc. I think there are many tables that exist on the web. One is called the Times Education, I think, and that gives all these kind of comparative studies. I don't want to, favor one institution to the other, so I don't want to. Yeah, but I
We will
would.
be sharing the institutions in the resources during the fellowship with the students. But of
Yeah.
course, as ma'am said, you need to focus on what you would like to do in the rest of your career. The path goes from there. Darshana would like to speak something.
Yeah, I just wanted to add that like much of the fellowship first 3 weeks are about self-discovery and understanding what is one would like to do, for the rest of at least like chart a career, chart a path for them, like what truly excites them. And I hope that will give a lot of, the attendees here vision clarity about what truly excites them and where do they want to see. And a lot of it involves finding your own answers. We can't give you ready-made answers like apply to these 5 universities and success is for sure.
Yeah.
And nothing works like that. Like whether it's Shobhana ma'am, whether it's Archana ma'am, or whether like any of the team members here, none of our journeys have been linear. They have come with its own share of ups and downs. And what we are trying to do here in Kalpana Fellowship is bringing all that consolidated learning into package so that the ups and downs, the amplitudes are not that high for you all, and but still you all have to go through your own journey to make the path that you want to walk on. So we can't make it for you.
Right,
No,
Darshana.
absolutely. Sorry, I was interrupting here, but that is correct. And however, the tribulations of being young and having a difficulty in front of you, that what can I do and where should I get admission, and all these things really are very real questions, and they need to be answered. I fully get the anxiety. How if I were to start again, I would make my path and then I would go for it, rather than गिरते पड़ते, यहाँ चले गए फिर ये होगा ये कर लिया वो कर लिया. No, you
Exactly.
make your path and this will be fantastic, and I really appreciate the efforts that you all are doing in bringing this kind of experience to the younger generation. That's
It's
really a big contribution. Yeah.
Indeed. So they will be learning about career action planning during the mentoring. So that is actually I think this is the core of the whole program that they have to learn first. So
Exactly.
there are other questions from Anushila. She's asking, how do we remove the fear of math at an early age, as most of us have it? So would you like to comment on that?
I think today there are so many resources. Go to TEDx and type math fear, and you will find a lot of good, fantastic, and motivating speeches and motivating talks, which are very short. No need to go for big lectures, just go for short inspirational videos on TEDx. You'll find to remove that. I do realize that because I also had that kind of fear, and I suffered a lot before I could get over it. You need to find good teachers. You need to make a one-on-one connect with mentors, which you are doing right now. So you are doing the right thing. And then, of course, there will be resources that will be put at your disposal. But you are the learner and you are the seeker. You need to seek knowledge, and if you know that you have a fear, that's already a learning. That's already a step forward. Then if you know it and then you do not do it, then it's not good. You need now to work on it. Very good.
Yeah. So there is a physics question now. So Kavita is asking, is there any contribution of wave, acoustic part, optics in the field of high energy physics?
What is she is in undergrad or postgrad?
Kavita, you can unmute yourself if you would like to speak.
Currently pursuing undergraduate.
Okay, good. I think the question is stemming from the fact that which kind of specialization you're going to pick up as a course. And I can tell you that forget about the walls between the categories of what is physics, what is particle physics, and what is electronics and computers. Everything is related to each other. Even to the biology, we will be related because we are doing medical physics and biophysics. And so whatever you will learn, those are the techniques that will be applied somewhere or the other to you when you come into your career. So go for it.
Of course, understand I think the core, understand the basics first clearly. You will fit in any field maybe later.
Yes.
What made scientists suspect the existence of Higgs boson? Anshika is asking.
What is the question? What made
scientists suspect that there is existence of Higgs boson?
Yeah. Okay. So, for example, when you look at the periodic table of chemistry, which you are more familiar with, you look at the groups and you look at the periods, right? And you see how were new elements found. They were found because there was a gap between an element A and an element B or C, sorry, and there was a gap which should have these properties of this group and that period, correct? Similarly, for the standard model, the four forces, which means that the electromagnetic force, the gravitational force, weak force, and nuclear force, they manifest themselves in such a way that they can explain the behavior of all particles. But the way masses are allocated was not understood, which means that why is the electron so light? Why is the proton so heavy? Why two particles can come together? These two particles can come together and those two cannot. Those kind of questions were there. And introducing the Higgs mechanism into the theories, into the one equation that I showed you, actually solve this problem. It explains the force between the Higgs boson and the particles and then how they acquire mass. So read about it, and it is not an easy concept, I understand. But again, TED Talks are great. Enjoy.
Indeed. And ma'am, there are questions and confusions related to certain topics. So as you mentioned that in India now you are actually trying to move the lab so that the cancer treatment can be progressed in certain way, and you are looking forward in developing that. So Ashi is saying, is hadron therapy capable of treating all types of cancers? It doesn't treat, it detects, right? Okay.
No, there are both things. She's right in terms of treating also, because tumors can be treated. And
Okay.
to treat something, you first need to know that it exists. It means that you have to make an image of the
Right.
tumor, where it exists, and the dimension of the tumor needs to be known. You can't just go shooting without knowing where is the target. It's something like that. So yes, what was the first part of the question? I forgot already.
So is hadron therapy capable of treating all types of cancers?
Or not all types of cancers, but difficult areas. For example, if there is a cancer tumor in the middle of the neck or inside the brain or near the lungs, where there are other vital organs. So if you are going to go for radiation therapy, normal radiation therapy, and you have your vital organs also exposed, it's very dangerous. So if you had a knife which you can put in without actually cutting the body up, but you can put this knife and just take out that tumor. That's how radiation therapy with hadrons works. Does it make sense?
I think it was Ashi's question. Would you like to ask anything in relation to that?
Yes, ma'am, I got the answer. It was very useful.
Thank you.
Are there any disadvantages of this therapy?
Disadvantages of this therapy is that it is very expensive for the moment, and we need to bring this to the masses in India, and that is my dream. So an appeal to all girls who wish or even like this field to study very hard and be ready in 3, 4, 5 years to come and join if I am successful to get
You
this
will
kind
be,
of.
ma'am. It is a good cause.
Ma'am, expensive is not a thing when you have to save someone's life. Like when your mother, when your family is there, na, so expensive things are not an issue. They are ready to give anything for it. But they need the life to be saved. That's what the point is.
Yes, so just on that, I can tell you that in India, an old generation machine, which means a generation of the 1990s machine has been purchased by Apollo Chennai, only one machine, right? And all of South Asia is actually the customer, so to speak, that can benefit. And one treatment costs anything between 25 to 50 lakhs. So now, depending on the tumor, of course, people who have money, they go abroad, they go to United States or they come to Europe and they get their treatments done. So imagine that Aam Admi in India has no option. They can, of course, have treatments of different kinds, but how effective are those treatments? अपने country में बोलते हैं ना कि जब cancer हो जाता है तो भगवान भरोसे चलते हैं. You are being treated, but you do not know what's coming next. And so when there are available other techniques for the rest of the world, why is it not available in India? So this is the question that I'm trying to answer. Of course, it is very, very difficult challenge because it's very expensive to set up a facility. But my goal also is to set up not only the facility, but a research center, an education center, outreach center, so that, young people like you all can come and do your PhDs and participate and then, become the world experts in the end of the day, because we do not have this community in India at all at the moment.
Yes, ma'am. We and you will definitely succeed.
Good, Ashi. Thank you for your question. And Anshika is saying we get to know about the particles in atom, electrons, protons, etc. after smashing them, but how we get to know about their internal structure?
So yes, physicists have been working a lot. I'm sure you know about the Rutherford experiment, where a gold foil was bombarded with alpha rays. And that's how the nucleus was discovered, because you would have expected images uniformly, but then you did not get uniform. You got the shadow of the nucleus on the screen that was put in front. In the same way, when you look at the structure inside the proton, you see the shadow in terms of other particles that are coming out from the protons, and the directions in which they go. Those are the tracks that you have seen in these very brilliant pictures, of which we take photographs and then we study from where they came and which two tracks together they then make up the proton, or three, and so on. And there are rules, of course. This is not just conjecturing. There are rules that are followed, and of course that's what physics is about, all rules and equations.
Exactly. And if I look into the equations, into what instruments I'm using or what, then of course, being a biologist, I get confused with that till the time I really go into the deeper maths by which they have been explained. So yes, I think maths is the foundation of most of the fields that we are doing right now. And so, ma'am, we have many career-related questions, but I think these kind of questions will get more clear once girls attend the fellowship program and further pursue what they would like to pursue. And here we have, again, what is the nature of Higgs boson? Anshika has asked. Would you like to comment on that? Otherwise, I will just take another question.
Nature of the Higgs boson. So for the moment, the Higgs boson was like a ghost until it was discovered. So we did not know that it was really there or not, Just like now we have other candidates to be discovered in the future. Many physicists have told us that we might see candidate particles like dark matter. For the moment, we don't know whether we are going to see them or not. But once we see them, we can say, yes, this theory is correct. So similarly, when the Higgs boson was proposed, and then it fit every theory, it fit the standard model the way it should fit. So now that we found it, it's like a new baby, So now we have to study what are the behaviors, how does it decay, and how many times does it decay in mode 1 and not 2, and if yes, why? So we are studying that now, and that's the big, let's say, reason why the accelerator is running in the next 3 years, where we will gather more data and study the Higgs boson in greater detail. Okay, does it answer your question?
I hope so.
Yes, ma'am. Thank you, ma'am.
And girls who are raising their hand, they can actually unmute themselves right now, one by one. Let me see who is.
Bharti, there are a few questions in the WhatsApp group.
Yes, please ask, Darshana.
Yeah, so I just wanted to ask question from Akshada Kadam. Ma'am, is Big Bang Theory and black holes both are different things or both related to each other? This is from Akshada Kadam. And then there is another question from Dasari Tejaswini. How is the data supplied around global electronic devices in different packages, like the like the data that is collected at CERN, how it is distributed to partners across the globe? I think that's what Dasari Tejaswini means.
Okay, well, again, I can't answer in few minutes these very big questions. That is one apology I have to make. What I would suggest to you that there are many Indian women scientists who are amazing theoretical physicists as well. There is a lady, I think she is called Shaulini Ghosh. She has done TEDx's as well on exactly this subject. There is Rohini Godbole, who is also our own Indian pride. So I would suggest take a deeper look, not just, I know it's a very nice, curious question. That's awesome. First step. But the second step would be go to the right source, take the time, 10, 15, 20 minutes to listen to a TEDx by some of the experts. And that would be my answer. I can start to try to answer, and it can take much longer, but I don't think we could take that time at the moment.
I think Shoini Ghosh has also recently published a book, a popular science book.
Fantastic.
We have actually Shobhana ma'am with us, and this was Shobhana ma'am from JNCSR.
Brilliant. Thank you, Shobhana ji.
And we have Astha. Astha, you can unmute yourself and ask the question. Or if Pooja Patil, would you like to ask?
Ma'am, hello. Ma'am, what inspired you to pursue particle physics?
So I have to say that, there are little nudges you get time to time, which you don't realize when you are in that moment in your life. I mean, in school, I had an amazing teacher who would always encourage me, and she would congratulate me if I did something good and so on. So she used to be very proud of me. Remember that model I was showing when I was in my school? There, my teacher was actually Sister Aquilina standing next to me in that picture. So she made me go to the assembly once, and she told me to explain what you did and how you did, etc. And she sort of kindled my interest in physics. That was step one. Then it was my teachers in Banaras Hindu University. That was also, we had fantastic lady teachers. I had 2 lady teachers who were amazing as well. I remember in BSc. And when you're a kid, you imagine you want to become a teacher like that teacher. That used to be my dream. And then when I went to university, then I said I want to become like my teacher, like this teacher, because you just admire. They become your role models. And that's how, step by step, I kept moving and eventually settled on particle physics.
Thank you, ma'am. And actually, these are never-ending questions, and we have many goals. And I believe you are at the time zone where we are already stretching your time to the max. So I would just like to take like another 5 questions. I think that would suffice.
Sure, yeah. We can take 5 questions, and I mean, I would be delighted to come back again another time and do another session with only Q&A, without any lecture or anything.
That would be wonderful, ma'am. Thank you so much and for extending that. And I cannot see one of the name, but okay, Pooja Patil, would you like to ask the question?
Yes, ma'am. Hello, ma'am.
Yes, hello.
So thank you very much, ma'am, to give for giving us lots of information about laboratories and about particle physics. I'm also a student of physics. I'm doing TY BSc. So I just want to ask one question, like, wh- what is a dark matter and how we explain dark matter in one line or in such a small or
Okay, good idea, good question. So imagine that you are sitting on your dining table, okay? And you have on the surface of this table, you have some knives and forks and spoons which are magnetic, okay? And they are all lying on the table without any order. They're just lying on the table. Now, if I take a very big magnet and nobody knows about it and I put it under the table, okay, what will happen? Tell me. किसका क्वेश्चन था अभी?
पूजा.
हाँ, क्या होगा बताओ? क्या होगा if I put a very strong magnet under the table and all these spoons on the surface are magnetic?
जो बड़ा मैग्नेट है वो स्मॉल मैग्नेट
नहीं, ये स्पून्स मूव करना शुरू करेंगे कि नहीं, ये बताओ.
हाँ मूव करेंगे वो.
मूव करेंगी ना, लेकिन अगर तुम्हें
Yeah.
पता नहीं है कि नीचे मैग्नेट है और ये मूव कर रही है स्पून्स, तो तुम सोचोगे ना कि ये क्यों मूव कर रहे हैं. इज करेक्ट?
Yes, yes.
ओके. तो इसी तरह से
Yeah.
जब अगर गैलेक्सीज मूव कर रही हैं और हमें पता नहीं है कि क्या फोर्स है, क्यों मूव कर रही हैं, सो वी आर ट्राइंग टू एक्सप्लेन. और जितना भी विजिबल मैटर है, जितना भी हमने मेजरमेंट्स किया, कॉस्मोलॉजी, एस्ट्रोनॉमी, पार्टिकल फिजिक्स, सब कुछ मिलाकर भी हम सिर्फ 5% एक्सप्लेन कर पाते हैं. तो ये 95% कहाँ है, क्या है? जब हमें कुछ पता नहीं कि क्या है, तो हमने उसको नाम दे दिया डार्क मैटर एंड डार्क एनर्जी.
Wow.
I hope that is
what
okay.
An explanation. And actually it cleared my doubt as well. Thank you for explaining in such easy manner. And I never heard this kind of explanation from anyone till now. Thank you.
Now you all will be my ambassadors and you will give this explanation of this question to everybody. Okay?
Yes, I will start with my husband. We have Professor Shobhana and she would like to add something, and I would like Professor Shobhana also to give the concluding remarks later. So yes, Professor Shobhana.
Dr. Sharma, this was a fantastic talk, very inspiring, and I really loved your explanation also of dark matter. I had a question for you about experimental science versus theoretical science, and whether you feel that girls or women are more hesitant to go into experimental science because when we are brought up, we are not encouraged to repair things with our hands or build things, and how we overcome that fear. I myself am a theoretical physicist. I was never comfortable, building things, repairing things. So I wanted you to say something about that.
Thank you so much for the question. And in fact, I belong to the same category because I grew up with a fear of, doing things. And you saw my nice pictures, right? But when I was at school, and of course, the big thing, let's say, push has to come from home and family. That is important because, taking the initiative of girls doing an education which is no different from a boy, that is very important. And I think that is happening. All of you are here. That is already an example and proof that all of you are studying, so that's great. Now you have to take it to the next level. Let me also tell you one thing, and this is a personal message, that I have lots and lots of students who are coming to my lab. My lab in summer every year for 3 to 4 months is full of students from everywhere in the world, also from India. And I find that Indian students, ladki ho ya ladka ho, they are unable to get started to do things with their hands, because अब उनकी गलती नहीं है. I'm not saying that it's their fault. They have not been exposed to the kind of work that we are doing.
No, I think it goes so deeply in our culture, no? We think that jobs where you work with your hands are lower status jobs.
Okay, there may be truth in what you're saying. However, what I would like to say is that we need to take lead now. And to all the girls, I want to say, especially the younger ones, you know, you look at the scientists in the world, and you look at the science leaders, science women leaders in the world. Everyone has got a helmet on their head, and they are working on the field. And I know मेरे साथ भी ऐसे ही हुआ रहा कि क्या करोगी फिजिक्स पढ़ के, क्या करोगी पार्टिकल फिजिक्स पढ़ के, एंड फील्ड में कोई जाएगा थोड़ी ऐसे ऐसे एक्सपेरिमेंट करने के लिए, बट now we have to change that thinking, and I think it's our responsibility, the people who are slightly senior, it's our responsibility to open the mindset, first of all to acknowledge that women can do, ये एक तो हम एक्सपेक्ट ही नहीं करते कि women excellence कर सकती हैं, चाहे वो theory हो या experiment हो, we do not associate excellence with women. So that's one thing, and you're absolutely right that we have this fear, phobia of not touching things and not doing things. I would encourage everybody, जिसको मन है, I'm not saying that सबको जबरदस्ती करना है, but whoever wishes to do must do. And this fear has to be taken out somehow, one way or the other.
I would like to add on to this. I'm Rubina Sheikh. Like I'm a postdoctoral researcher here in Finland, Applied Physics Department, and I'm actually experimental physicist, so biomedicine related stuff. So we are preparing the device for osteoarthritis related problem. So I was always having this problem of not seeing the role models. And thank you so much for an excellent talk, and congratulations for your excellent work you have been doing. Thank you so much for it. It's also inspirational to see, but I also see the similar problem here in Finland as well, that not many females are up doing work, especially in STEM. And this is a global problem, I would say.
Yeah, it's about 20%. In some countries, it is 15. In some, it's 25. So the average is 20. In India, at least, girls study a lot. They study STEM. They do very well. And every time, there are girl toppers everywhere. But then somewhere in the middle, between PhD and postdoc, they disappear. And that's where we need to plug this kind of leaky pipeline, as it's called. And I think this Kalpana program is going to be a big step towards that. And I would like to see people from this Kalpana project into the mega science projects. Let's make the link. Let's make the roadmaps on how many of these PhDs or young students set their mind towards mega science projects. Any of them, whatever is their interest.
Exactly.
We can.
Thank you, ma'am, for such a wonderful talk and simplifying so many concepts of physics to all the people, because we have students from all the fields in STEM. And here, Dr. Darshana would like to add something, and then we would like to close the session. But we will keep the open floor for the students once ma'am leave for this particular session. Thank you.
So I just wanted to add one thing to what Archana ma'am and Shobhana ma'am was saying. At VigyanShaala, we have set ourselves a very audacious goal that in next 10 years, we want to, or sooner maybe, we want to realize the goal of million maker girls. Maker means people who are doing things with hand. And as Shobhana ma'am and Archana ma'am was sharing different bits, like how people who are doing carpentry or people who are building things with their hand are not considered super high skills in that sense. But if you look at the whole trend of maker spaces across the globe, people find pride in building their own furniture, people find pride in building their own electronics. And we as particularly Indian children are super protected and are oh, if you touch a drill machine, you may get hurt. I'm still afraid to touch a drill machine, but I have told myself that in next 1 year, I'm going to perfect some of these skills where I'm making things by my hand. And we want to lead by example. And I think this is the tribe that we are determined to build, that million maker girls across India. So, and thank you, Archana ma'am, that you said that we can make a connect between here and the mega projects. And we would be very, very happy to sort of pick your and Shobhana's brain on that and sort of take it ahead from here. So thank you for this particular bit. And over to you, Bharti. And yeah.
Once again, it was a wonderful session and a nice inaugural talk for second Kalpana cohort. Let's dream our journey together and let's go forward. And even dream a higher STEM career. Please don't stop yourself with small dreams.
Thank you very much for having me. And all the best to you. And I mean, this is a big bang start, and you don't know where it's going to end. So just make it higher and higher. The higher you dream, the higher you will be able to achieve, And I know both of you are so committed. Things will happen naturally. So all the best to all the attendees as well. And I really appreciate you invited me. And I'm ready for any Q&A anytime you think you would like to do.
Absolutely. For sure, ma'am. We will keep you posted. And thank you for giving us
Thank you.
Yeah. Bye-bye.
Thank you. All the best. Bye-bye. Bye, everyone.
Bye. Bye.
Bye, Shobhana.
Students can stay here, and we will still have a 40-minute session.
Shobhana, can you switch on your camera, please? We want our students to see our mentor. So
Okay.
I just wanted to give a brief to all the girls about Mrs. Shobhana Narasimhan, who is spotlighted on the screen now. So Professor Shobhana Narasimhan is a professor of theoretical physics at Jawaharlal Nehru Center for Advanced Scientific Research, Bangalore, and she is like our inspiration behind the reason why we are building this Kalpana tribe. For me personally, me and Dr. Srishti Arora, she's been a long-standing mentor, and the philosophy of her mentoring, we now want to sort of spread and channelize into this building this big community. So, Shobhana, do you want to say some bits? Sorry,
Okay.
just impromptu. So, but still, we would really like.
That's okay. So, good morning to everybody. I'm very excited about the Kalpana program, and I think you will all find that it really transforms your lives, your careers, and what you will experience over the next few weeks will probably shape your future career in very important ways. I'm a physicist, I'm a theoretical physicist, and I've been concerned for a long time about how very few women go into science, and also sometimes because we're a minority, our lives become a little bit more difficult. We feel a bit lonely. We don't have people who can mentor us, who can support us. And so I've been working on building networks of women who can support each other in our choice of careers and how we help us make decisions, help us if we face difficult times. So I think the people you will meet, the other women, the other students in this program, the mentors, they will all be a really important part of your future lives. And it's great that you can form this network and these bonds at this early stage in your careers. And I also want to say that you will meet not just women, but men who will be supportive. And that's very important, of course, that, women can support each other, but we also need men who are supportive. And certainly for my career also, the women friends and colleagues I've had have played an important role, but I've also been fortunate to have the support of many wonderful male colleagues and mentors. And I'm sure that will be true for you also. I wish you all the best, and I look forward to seeing all of you flower and bloom over the next few weeks. Thank you very much.
Thank you so much, Shobhana ma'am. And girls, she is a constant support to us, and with Dr. Pratibha Jolly, who is ex-principal of Miranda House. And so you will be, if you come up with any complications, any difficulties, which can be sorted by someone's advice, definitely come to us, and probably Dr. Shobhana will be available and Dr. Pratibha Jolly to advise you once in a while during your journey as well. Thank you, ma'am.